Okay. Okay, thank you for the introduction. Welcome to my talk. I'm very honored to be here in Bangalore and present this keynote. As always, keynotes are a very nice thing to have because you can actually explore a little bit more and tell some stories around why things are the way they are. And I've used the opportunity here to not only talk about the topic here, but also to give a bit more background about actually how model-based testing has evolved. So this talk has this aggressive title about eliminating modeling out of model-based testing. Now this of course is a very radical statement, and that's why it's in quotes. This actually came out of a conversation that I had with our VP of sales, who has been talking with me and has been saying, Stephan, now you need to come up with the next big thing, and what about if we just remove modeling? And I said, Clark, this is crazy, right? Model-based testing based on model, how can you remove modeling? Impossible. So the keynote here will go to this matter, how we can eliminate this modeling, and this is the idea of the keynote. So just very quickly, I get a lot of questions. How do you like Bangalore? How's your first time in India? Actually, I'm not the first time in India. Actually, our company is also even headquartered, a office here in Bangalore. That's where actually my guys are sitting. So I'm here every quarter. So I'm happy to be here, and we work a lot with you guys. So we actually distributed it quite around the world, and it's a company was founded already 20 years ago. Basically, soon we have our 20th anniversary, and we've been always working in test generation and model-based testing. So this is the outline, so let me just start to dive in. So model-based testing has been around for some time. Does actually somebody know here when we have had the first publications on test generation, let's say? You probably won't believe this, and it's actually even almost before I was born. So we're talking around 40 years ago, in the 70s, that we have the first kind of papers that discuss algorithms, how to generate test cases. So even my father, he used to work for IBM. He told me, son, when I was working, I already had people come to me and say, why don't you use model-based testing? Right? So actually, this means model-based testing actually has been around for some time, and it has undergone actually quite a lot of evolution, right? I'm going to talk a lot about this in the next slide in context of modeling, but one kind of big milestone for me at least is that we have the first industrial standards actually on what is model-based testing and what do we expect, what are requirements for model-based testing tools, which appeared around 2010. Then another big milestone was in 2015. We have now officially, I don't know how many of you know ISTQB, the International Software Testing Quality Board. They certify people, and they have actually created a module for certifying testers in the skill of using, and it's a foundation level module on model-based testing. So this is no longer just some kind of technology thing. This is really now something that has is accredited. We have actually lots of data and lots of cases where we can show that there's significant effectivity improvements that you can achieve with model-based testing, and it is an accepted technology that is now already starting to get widely deployed. But the big question still is, well, why is not everybody using it, right? So can you raise your hand, who is using model-based testing in the current kind of production testing processes? Okay, so we have a few hands here up, but it's clear that not everybody's raising their hand, right? And when we're not all raising our hand, we have to ask the question, why is it like this? We have a technology here 40 years ago, the foundations were laid, right? Why 40 years ago it did not work, right? And here there's a clear answer. Actually, 40 years ago, we did not have a phone that had a multi-core processor with GB of memory in it, right? That time we had a single processor, and maybe we were lucky when we had a GB on the hard drive. But so test generation is a very computational complex problem. So about in the 90s, we started seeing multi-core processors. We started to see the RAM getting up to levels that you can actually do some real computation with machines. This is why you will see, in around 2000, that the people start picking up and actually deploying it in an industrial context, right? But still, now that we have powerful machines and what used to be craze in the 80s where you had to send your computation jobs, right, is now basically only a lab. And okay, now the thing still is that there's one fundamental thing. As testers, we used to work with test cases, right? And many of us, start from test descriptions, test plans, call them what you want, manual tests. And this is, we think of tests, right? Model-based testing is about modeling to derive tests. So for the first big step for testers to get started on MBTs, to start to work with modeling, which is not something that they consciously do, that they actually do in their head, but they are not writing documents in that style. So again, we're getting back to this question, how can we eliminate modeling? So let me just talk about MBT for those of you who are new to this. So I would call MBT 1.0 basically what we started around 2000. It is the ability to generate test cases for models of functionality, right? So we are not specifying test cases, but instead we specify what the system's supposed to do, its operation, both aspects about how is the how's navigation through this system, and also what is the data that I want to see covered in this context. And then basically via automatic test generation, we get the test sets generated from this. Because testing is and will always be an infinite problem, I have always infinitely many ways on how to do a test. We need to find out ways how can we actually focus our tests, right? Now this is done by the so-called test targets, right? And by the way, this is now not only unique to Conformiq, but to any kind of model-based testing tool which is in the space. So we specify test targets to say, actually, I'm interested not in all of the tests, but these tests that cover these requirements. Or I'm interested in the test set that covers my problem in the least amount of tests, with the least amount of test steps. I want an optimal test suite. I don't want to execute, loops, as many, 1,000 times. It's enough if I cover this loop once, right? So this is the first generation. This started around 2000. Okay, but then the other aspect of this is that when model-based testing got started, actually the modeling notations were, let's say, it was a ride. If you go back about 10 plus years ago, these first real test generation tools that go through system modeling, they used functional programming languages. And I'm saying here seriously, they thought, users are able to use functional programming languages. So you probably have heard about C, right? That's a programming language. But there's actually a language called B. And this B language is a functional, programming language. There's another similar language. For example, this is actually a language that Conformiq has used for, or is still using it as part of its core, which is called Lisp. I don't know, you cannot really tell from the screen anymore, but I bet even those of you who've done programming will be challenged to express themselves in this language. I still remember reading, it's a good book, Introduction to Model-Based Testing, written 2006, Mark Utting and Bruno Legar. And, I read this book. The introduction, first chapters was great. Then I get to chapter 3, here's your first model, and they start with B. And I was thinking, oh, come on, how is this going to work? I mean, firstly, a tester most testers have not been exposed to programming. And secondly, even those who have been exposed to programming, they will suffer, right? Okay, so both of these companies that have been using these languages realized maybe this is not for the mainstream. So actually it went on, and actually new companies came out with model-based testing tools. And the clear trend about 7 years ago was like, yes, let's use UML, yes, let's use general purpose programming languages. Some tool vendors said, hey, it's enough if you use C#, right? Everything you express in C#, the entire model, right? Other people used UML as a path, but UML has this problem that it's a generic language, and actually it was designed, I think in the 90s, early on. The original purpose was to document systems, not to describe kind of execution or to do real model-based engineering on it. Ever since the 90s, people have been trying to extend UML to become expressive enough to actually express things like having, can somebody put this away? Express executable modeling. So, now I got completely kicked out. Okay, fine, thank you. So, So you need to complement UML with something to get it into a shape so it can actually express data and values in its flow. So some people went for languages, so-called object-constrained modeling language, again, a very formal language. Some other people use Java. So basically what we see in this phase, about 7 years ago, this was the way how we have approached modeling. Now still we had the challenge that there was a lot of reliance on programming languages, and again, not many testers are necessarily come with the skills to do this, especially when we go to functional testing, right? We have a lot of people that actually are testers by choice, right? They have said, I was a developer, but now I want to do testing because, it was too much for me in the programming, right? So I have met all kinds of people, and usually, when you model with Java, you have the people saying like, yeah, but that's Java, I like C#. Can you do the same thing also in C#? Right? Then you get this kind of discussion. Do you use Emacs or do you want to use VI? I mean, there's like battles about this stuff. So these tools actually now again are on the decline. So this was the next kind of period of model-based testing tools. Then we finally get to the last phase in modeling, that where we are today is that the most successful to this day to bring everybody into model-based testing have been the deployment of domain-specific modeling languages. So these are fully graphical languages where everything is expressed via graphical entry, right? There's no more programming involved in this. And this is just one example here. There's more examples of such domain-specific modeling languages. And yes, even domain-specific modeling languages are not necessarily graphical. They can also be textual. But I mean, for the sake of argument, let's just call them graphical. Okay. So that was the modeling part, right? We have just said model-based testing is good for test generation, right? But actually, model-based testing evolved. This test generation went into the core. And what we then saw that the tools actually realized that not only is it great to generate tests, but it's a great way to actually automate my testing process. We can link all the information together, and we can put basically the MBT kind of test development approach as a way to coordinate all these things. So we can go to ALM or requirement management systems, download requirements, link them to our models, and generate tests. And then generate these tests. These generated tests will be automatically linked to the requirements because it's the engine that connected the requirements here to the tests. So there's no manual involved anymore here. Similarly, we can not only, we can generate from these tests, we can transform them into test plans. At the same time, we can generate scripts from that, that we have our existing frameworks. Or if I have a keyword-driven framework driven by Excel, I can produce the Excel kind of sheets that drive my underlying keyword-driven framework. So that I call MBT 2.0. And that's really a step beyond pure test generation, right? This is what we need to understand. So also what falls out of this is like we have actually one way to keep everything in sync, right? Like the moment I update what I want to test in my model, I actually keep all of the artifacts in sync. There's no way that I can actually really get out of sync. The time that I export these tests, I do that simultaneously. Okay, so that you can say, okay, now problem solved, you have a nice modeling language, right? You have this full integration, I can automate my testing process. Okay, but then I say, okay, I want to get started, okay? Then you download tool XYZ, you starting on it. You look at this. You have written tests before. And then see, like, oh, it's very easy. You just have these things here, you just drop them, and you go like, but, Stephan, I don't know. I've never written a model. How do I write models, right? And, we live in a time where it's, I think, no longer acceptable to start like saying, oh, you need to go to training here, training there. In a month's time, you will know how to do it. No, you need to get started like this, right? So that's where we get now to the point, eliminating the modeling part. So it is actually the way how we, quotes, eliminate the modeling part is by knowing that there is existing assets that we have that we can actually use to get started on the modeling. In the same way that we create tests, we can also create models, right? Because when I started working with these people, after I joined Conformiq like 8 years ago, I noticed that, sometimes people would have a document open and were just kind of copying by hand, drawing what they're seeing on the left-hand side, putting the model over there. I started wondering, like, why are you basically copying stuff? We can automate this, right? We can automate the creation of model artifacts. You should be only there tuning stuff, right? You should not be there to just literally translate one-to-one from, let's say you look at a screen, you should not be redrawing screen objects on the right-hand side. When you have the screen on the left, you should capture that automatically and it's there, right? So existing assets, so means to create models automatically. What that gets us to is really the fully automated testing process. So we can import the requirements and track requirements changes automatically. I don't know, somehow this pointer is not working. We can update our requirements, our test management systems automatically. We can automatically execute the tests. We can maintain the connection between everything. So this is another view of the same, this more process-oriented view about the same figure. So we have assets. For example, we have manual tests. We maybe have Gherkin specifications when we go into a more agile-oriented process. We have just flowcharts, whatever that may be in whichever drawing tool you have. We have maybe business process flows from our business analysts, right? And then we can take these in and put them in context of testing, right? Because it's not enough to just have a flowchart. I can draw a flowchart in Paint, in anything I want. I cannot generate tests from that. And why is that? Because it's just a couple of shapes, right? I need to refine that. I need to say, what is the shape meaning, right? And this is what I will do in the modeling phase here. And then I will generate my test cases. And then when I send to my test execution, and that will also fully go automatically against the system under test. And again, the automation assets is one aspect that we can also import, right? I have screen scrapers. I have recording tools, right? I can record traffic. All this stuff I can also import to the models. And I don't need to recreate that in the modeling, because the modeling at the end of the day connects, the application interface to the actual business logic. Okay. So how does this work? I give you a couple of examples. Here's one flow. So let's say I have flowcharts or something like business process model. Here's an example actually about a business flow created using Visio, right? So if I have this Visio diagram, I can go and I can import that, and I can already get this diagram all pre-configured, meaning the flows that I have in here will appear as flows, and I will get actually some first actions which represent what's happening, right? So they will kind of simulate placeholders for real testing actions that have to be put in here. So the modeling language concept here is I have an activity, I need to specify the actions, the interactions with the system that actually reflect that task. Let's say I log in or I register to a system. When I register into a system, I have a specific application. I need to fill out a form. I need to click the submit button. So these are the kind of actions that should be filled in here by the tester, not by the business analyst, right? So the tester knows how to create an account or how to log into a system, but the business analyst does not matter, right? The business analyst just says, log in. I don't care how you do it, right? Tester adds that information. And then also only the tester knows what are good names or good user password combinations I need when I execute my test. This is the second thing we need to add, test data, right? And then we give it to the tool and say, look here, I've constructed, I've told you how it fits together, generate me the test, and from there you go automatic, okay? So this is this next step. Now here, as we've talked about, I've talked a lot about, you have to fill out a form and you need to click a button. And the question is, well, from this flowchart, I don't get this information, right? Because here, business analysts don't think about user interfaces, right? For them, it's too detailed. So we can also combine multiple ways of importing data and just connect this information together. So imagine that. I have a website, I scan it, and I already get basically the representation that I require for functional modeling, right? And then I can just basically go to these models that I got from my Visio import and just refine them with these actions. So here I get already all the information. What are the forms? What are the buttons? I don't need to do anything about it anymore. So modeling becomes really only the part that you just need to connect the information, right? And remember the screen that I showed just before, empty? All this stuff you would have to do on your own if we would not have these importers. And of course, we want to be much faster. And of course, you know, the question is, well, Stephan, what happens? I don't have the application. It's under development. We don't have a final design. We cannot record anything. Then you always have as a fallback, okay, you can here already mock basically your UIs, right? And this way, go ahead. You don't need to wait for the development. You can just go ahead and testing. Go all the way to automatic test execution. So the only thing you need to do at the end is just to connect these things up once the application is there. So you can, basic model-based testing is like working with a virtual system under test. You don't require even really, the last step is the execution is almost more like a validation. When we have test generation, we gather all the data about, you know, how the system will respond to what we're doing. We get a first level of validation. So similarly, what we can do with UI interfaces, also with APIs, right? So you may say like, okay, Stephan, I'm not working with user interfaces. I have other systems. I have mainframes. I have SAP systems. No, I actually have web services. No screens, nothing, no buttons, no forms. No problem. Basically here we have schemas in this world, right, which are very similar to what we have as wireframes for UIs, right? So these schemas can also be imported and create information that you then again use. You define just the messages based on the schema, right? And again, we can fully automate the pipeline. So, and what goes for SOAP also goes for REST, right? There's no limits. Basically, you should challenge yourself. Whenever you're starting to recreate information, you should say, hey, stop. No, let's automate the process, right? We don't need to redo stuff. These schemas exist. The development is using these schemas. Nobody has to do any work, right? Why do we redo everything? We should just use it. Finally, Gherkin, you know, BDD is a big initiative, especially in the agile domain. I've actually watched some of the presentations yesterday on the topic, and actually even we are working with BDD, but let's say we're working actually more with Gherkin. So essentially we're not doing BDD, but we're doing BDT, behavioral driven testing, right? And what does that mean? So for example, we can take these Gherkin feature files, and just like we do for the Visio files, convert them actually into these flowcharts. So meaning we can overlay and compose and put these scenarios together for one feature file or for more feature files. And here's now something interesting. We started doing this about half a year ago. What we've actually learned is that we have a lot of overlap and consistency issues with Gherkin, right? I mean, people tend to repeat things without knowing. They actually, if you notice this example, it looks like valid, 3 scenarios, but actually I can tell you, one is completely redundant, right? The first one is an exact subset of this one. And it's not that this is an artificial example. I've seen real Gherkin from real production groups where this is actually commonplace. And you wonder, why do I have to do this extra thing? So we can actually do optimization as part of the import. We can compact it, we can tell you, this is where things can be do more optimal. We can still follow this stuff, right? I mean, it's not that we're not covering it, but we can just do it better. And then once we have constructed these models, we are back in square one, right? So what I've just discussed about before, you do the automation, you use information from your user interfaces, web services, you put it together, you go to execution, you're done, right? If you're interested about this topic, actually I want to point you to a talk. I have had a talk about this very specific topic from everything, what is Gherkin and what is BDD and how can we put it together. So unfortunately I only have 30 minutes here. And then finally, when we have Gherkin, then the question is closed, well, if you can do Gherkin, then what about my test plans? I have my ALM loaded with test plans. And I have manual testing right now. Actually, I want to automate my tests. So, okay, what about this? What about we actually import and compose these things just like we do with Gherkin? We automate them, and this is out there, right? You don't have to reprogram everything here, but actually you can fully automate the process of generating tests for you, manual tests here. And yes, there will be work involved here. I do realize that in test plans, there's also activities in here that are probably not kept up to date, etc. But this is part of the process, right? To get something automated means we need to get it in a shape that it's actually executable. But the process flow is exactly the same. And the moment you give me other examples, I will just tell you, they're actually all kind of subsets of the same problem. We either try to import kind of traces or scenario, combine them, right? Or we have, you know, the flowcharts coming in already. So I can't even tell you the way how we have solved this in Conformiq is that we actually have only one engine that's doing this. And this is just mapping the presentations, these different, is it Gherkin, is it manual test? Actually, for the engine, it does not matter, right? And if you have some other custom formats, it's no issue. So now, this all sounds very theoretic, but the point is we have this already out there. And actually, there's even more people that have this out there. But just to kind of give you an example from one industrial project where we have been using this. So these are just classic design data. So I tell you, even if you start scratch from modeling, these are numbers you can expect to see, right, when you get started on this. But the interesting part here is this. Actually, these people said, okay, I mean, all these kind of things, I can get 70% better in getting my tests automated from scratch, no matter how I do modeling, right? I can get 51% improvement in my test, speed up in my test design. These are all great numbers, right? But I still have to do modeling, right? I mean, for some people, they would say, wow, that's great. But you know, then people come say, yeah, but I still have to do modeling, right? So this is the part about modeling. So basically what this says here is like, okay, it is of course project dependent, but here we've had some real case study. These are real projects, right? And also these are real numbers. These are not Conformiq numbers. These are numbers from our customer, and usually when we believe it's 70%, they say, no, let's say 50, right? So these numbers, for my taste, are even downgraded, right? So basically here, there was one project, one application. They had their existing tests in Excel. They imported them. It took 51% of, basically saved 51% of the time, you know, to create the model by using this reverse engineering or importing the manual tests and creating the model. This was even more drastic, right? Where actually the customer used in another project, not Excel for manual test specification, but this business process testing in the HP tool. And this continues. It doesn't really matter if it's HP, if it's Raleigh or whatever we have, right? I mean, wherever we have a test plan, the same applies, right? It's just a question of reading the information and normalizing it and transforming it. 75% is actually loaded here below, and as you see, you know, well, okay, the modeling can take time, right? But you know, of course, when you're importing it, it just becomes the engine kind of crunching on it and pushing it out. So this, I think, is why this is so important to understand. This is not just a kind of a theory or an idea. This is practice, right? And again, there's even industrial tool. It is not an academic idea. This is something that's in industry already today. So what I wanted to say here as basically my final note is that when you start with MBT today, you should actually think about from the start that it's more than just test generation. A lot of people are still in the mindset that was out there 10 years ago, that MBT is the same as test generation. Actually, MBT is a facilitator, right? So not only can we integrate with everything, but at the same time, you should expect today, when somebody comes with a model-based testing tool, you should challenge them. You should go, listen, I don't want to do this extra work. Give me the way how to get the model. And you should even challenge me. So if I have something you have that you believe you can get models out of, you should come to me and say, Stephan, you said I can have everything done for me. Give it to me, right? Challenge everyone. It's doable, right? And once we have this done, we get the classic benefits, everything there, right? I mean, so I've not talked about this in this presentation a lot, but of course, we've seen these numbers from this project. So effectiveness, test coverage, we can trace test coverage, we know what we're testing, you know, consistency in what's generated, optimizing the inputs that we have, everything. And, you know, get these control, visibility, automation, integration, and speed. So especially automation, automate everything, automate. Right? And as we're all moving into more agile ways of working, that's what we need to do. Right? We need to have at the end as testers an output that we can send to Jenkins, that we can say continuous integration takes it from here. Every day we build, every day we test. No, quotes, no humans involved. Yes, I wanted to avoid this topic, but that's actually MBT 4.0. That will be for another talk. So I thank everyone for listening to the talk, and I'll be happy to have questions, not right now or, you know, after in the breaks. Thank you for your attention.
Check.
Questions?
Thanks, Stephan, for making us lazy. This seems to be taking our job, It's doing everything, whatever a tester does, and whatever we foresee as, the future for getting something automated at the very first stage. So thanks.
Okay. I'm sorry, I cannot hear. There's a lot of echo standing here. Can you just comment? You have just comment or question?
No, it's comment plus question. So now when we,
Okay, thanks.
Am I audible now?
Yeah, now it's good. Now I can hear you.
Okay, so I was first saying thanks to you to making us lazy actually, because you are taking our job. You are doing everything, whatever we do.
No. See, this is already one fallacy. We are not replacing the human here. We're making him more effective. How much time do you actually spend on thinking, testing about your system? How much time do you spend about just coding or just writing, right? We want testers to think about what they test. Go further. I've been saying that in other talks, that for me, model-based testing is like you're trying to squash a bug. There's a dark room. You don't know where the bug is. So MBT is like you give them a flamethrower and you say, where's the bug? Of course, you will still need to point this technology, to find the bug, right? We need the tester. The tester is the person that knows the system, that knows how to point this technology. But let's remove all the mundane work. Let's focus on our job. Sorry for interrupting.
Sure, and that's true. And my question comes in, this talks more towards the testing phases of future. But when we talk about DevOps and we go into the Jenkins to ensure that builds are being tested well, we talk about unit testing done, we talk about parallel development, parallel automation. So is there anything that you are thinking over for the next of the Conformiq as part of integration with the Jenkins and CI/CDs and all?
Yeah, so in my opinion, we are already there. I did not show this last piece, but at the end, Jenkins does not care where is the automated test coming from. Is that coming from Cucumber? Is that coming from a human? Is that coming from Conformiq? Is that coming from my other kind of tool that produces automatic test execution? So already today, these tests that are there not only are executable locally, but also on the servers. You can upload them to the cloud, you can execute them there. But it's already a process that's in place. The trick is just how to get to that automatic test with as little, with as much automation as possible, because after that it's just you drop it and put it into your continuous integration system, and it's done from there. The thing that we're actually looking at to kind of tell you what are we actually looking at, right? We're looking at how to optimize this even further. Right now we're still working with regression packs where we say that's the functionality, that's what we do. We want to use much more analytics to even focus more of what are we actually testing. We want to tell people already in the modeling, we know the defects are here. Are you covering them in your model? Things like this. So we want to even help people, remember that flamethrower? We want to give this default position where you should shoot it at. So we're closer and closer to getting defects, getting, the system. A lot of model-based testing is firstly about knowing that the requirements are fulfilled. This is the number one thing. Number two thing is even finding defects at the same time, right? So continuous integration is there. We can give you information how people have been doing it. People are doing it today. I just have spent some time in Delhi 2 days ago, and we've just set this thing up again. So it is definitely there.
Distributed execution or remote execution is something that Conformiq does?
So Conformiq is mainly about test design. So model-based testing in itself actually does not necessarily automate the test execution. So the MBT part actually just generates the test for test execution. The actual execution is done by classic systems. So for example, if you have existing systems that you're using, right, for automation, keyword-driven frameworks, there's HP tooling, what else is out there? Tricentis, other tools, Parasoft, whatever tool you have today. MBT sits on top of that. Also, Conformiq also offers Selenium-based solutions where you can use that, but we're flexible. We're not a test execution provider necessarily in the first place, but only in the second place.
That means you would be piggyback on the tool that is underlying for automation made by, for example, Selenium. So Selenium uses Grid for distributed executions.
Exactly. So actually we have also a solution that works on Selenium, but I mean, if you have existing solutions out there, again, it's not just about Conformiq. Any model-based testing tool should not have a problem in saying, no issue. You have your own Selenium-based solution, we can generate the tests into that. Okay,
Thanks.
that's it.
Thank you very much.
Okay.
One more question.
Sure, sure.
Have not focused much on the requirement management to the test plan.
Huh.
The requirement management, if it is the Word or PDF or any other format, like are you automatically fetching the requirements and then creating the test plan, or the test plan is the manually created?
No, the test plans basically are generated, okay, there is the model, which is the flow chart, right? Then what we do is, so the model is, basically the flow chart is one piece. The next thing is the requirements. The requirements are mapped to the flow chart.
By manually?
Yes.
In the Excel sheet, I saw the test plan. That is
Yeah.
the second input you are giving. Right?
This is one way of, yeah, sure. This is about how do we get this flow chart? Do I need to draw it or can I create it? If I already have existing tests, I tell you, we can build the flow chart for you.
Even the flow chart for the first baseline, whether it is first created manually,
Yeah.
for feature in Visio, later only you are actually like fetching the parameter and then refining it. Am I correct?
We are importing the information and then we're making it suitable for test generation. So the thing is, Visio alone is not enough, right? Even test plans are not enough because they don't, you don't know what is the object, real object you're linking to. This process, this is basically this refinement is what we're doing actually. And of course, as time goes on, as we getting into AI and machine learning and everything, right? These tasks will gradually even fade away.
And this flowchart will carry the bidirectional traceability also to the test cases, to the requirements?
They will, so the requirements go linked to the model, and then basically we generate the tests. And basically, as it's a computer who's doing it, it's keeping the link between requirement and test, as specified in the model. The thing is, now you say, my business analyst or my system engineering people change a requirement.
Yeah.
What's my impact? So right now, what we can do is, we can actually flag to the user, we can say, okay, update with your ALM system. Then we see, oh, this requirement has changed. You can navigate to the model. This is where you cover the requirement. You can say, oh, here I need to change the way how the system works. So it's very interconnected, everything, right? So, but it's not, I mean, some people these days start to move into this, for example, they have agile way of working. They store actually Gherkin in their requirement systems, like their user stories, right? So Gherkin is starting to become a requirement definition language. So in that sense, yes, we can generate models from that. But if you just have if people in their requirement system just put English text, right, anything, we're not yet at that point where we can say, oh, we can automatically determine, this would be the flow chart that's actually covering this thing and piecing them together.
One final actually is on the test execution. If multiple iterations like 50 to 60 is happening, the tool is capable of capturing all the iterations, console rate, and then manage it in the test management. Am I correct?
I'm sorry, can you repeat that?
If multiple iterations in the test
Iterations
execution,
yes?
test execution is now happening for multiple iteration, is this test management is capable of capturing, logging, and showing
we are
all
not,
data?
again, the test management is external system. We're linking to that. Yes, you can work with different versions, release versions of your product. Absolutely.
Thank you.
Okay. Thank you.